guys, I'm Dave from Fictiv, and this is part of our Hardware DNA series where we demystify how physical products are made. Today we're going to take a look at the evolution of Nintendo controllers, starting with the first NES system, moving through to the N64, and then finally ending with the Wii U gamepad. First up, I want to talk about my favorite mechanism as we move through the evolutions of the controller. Hands down, it had to be the evolution of the joystick. The joystick was first introduced in the N64 system, and then we saw it in the next 3 generations of controllers as well. The most amazing thing about this mechanism is the size and complexity and how it changes over time. So the first joystick was in the N64, and this is an analog joystick that uses optics and rotary encoders plus gears to actually measure the travel as you move the joystick up, down, and left, right. So as we move through the evolution and you look at how the GameCube and modern joysticks actually work, it's not just the size that is remarkable and the difference between these two mechanisms, but it's also how they measure the movement. In modern day joysticks, we're actually looking at using 2 potentiometers where as we move the joystick around, we're measuring the difference in resistance in the potentiometers versus actually the distance of the rotary encoders and gears in the N64 joystick. So that was my favorite mechanism, but now let's take a look at the evolution of the form and design moving through the ages. So as part of the design, the ergonomics is incredibly important for any gaming system. So it's really interesting to look at the square boxy NES system to then a little bit more curved, a little better ergonomics in the Super Nintendo system, all the way through to a 3-prong controller that can be held in multiple different fashions. I preferably held it like this. And all the way through to a boxy square design as well in the Wii U remote. What I think is interesting is along the lines of ergonomics comes the challenges in mechanical engineering as well. When we looked at the number of components, slides, and actions on an injection mold that would have gone into the NES system, and we compare that to the interiors of the N64 system or the interiors of the Wii U remote, it's incredible to think how complex and how far we've come in the ability to injection mold and build repeatable systems in plastic. So when we think about the evolution of the PCBs, going from a single shift register in the NES system, then moving to the first microcontroller in the N64 with a 32-pin connector, all the way through to the Wii remote and the Wii U gamepad, it's incredible to think how far we've come along in the evolution of PCBs and design. Specifically, if you look at the evolution from a Wii U remote and how the PCB and the number of integrated circuits that are on here, compared to the NES system that has a single shift register, it's remarkable to look at how many components are really on this. From the microphone, the head jack, the IR sensors on it, there's even a camera on the back side, to all the different accelerometers and chips that are on this. So that's a high-level overview of what we found interesting in the Nintendo Teardown. For more information, make sure to check out Part 1 and Part 2 for an in-depth look at all the different subcomponents and mechanical design behind these controllers. For more hardware goodness, make sure to subscribe to our newsletter and get the next Teardown in your inbox.